Many breakers can present challenges within electrical panel boards. A primary concern is increased panel occupancy. Many breakers, despite their name, can take up more space than standard breakers, leading to what is often described as excessive fill. This overcrowding can hinder airflow and make it difficult to access and service individual circuits. Overcrowding can lead to overheated wires and increased risk of electrical fires. It can also create difficulty in troubleshooting and servicing circuits. Another significant issue is the limitation of neutral spaces. Panel boards are designed with a specific number of neutral terminations. Many breakers can exacerbate this problem, particularly in panels already nearing their neutral capacity. This can lead to improper neutral connections and potential imbalances in the electrical system. Furthermore, many breakers sourced from general retailers may not always adhere to the precise specifications of the panel board manufacturer. This non-standard fit can introduce safety hazards, as the breakers may not properly seat or make reliable electrical connections. The cubic inch capacity of a panel board is a critical consideration. This refers to the available space within the panel enclosure for conductors and connections. Installing many breakers, especially in large quantities, can easily exceed this capacity, potentially voiding warranties or creating a fire hazard. The National Electrical Code, or NEC, provides guidelines on volume allowance required per conductor. These requirements are designed to ensure sufficient space for heat dissipation and safe conductor management. Many breakers, due to their compact size, can sometimes lead to a violation of these volume allowances. Firstly, many breakers can lead to difficulty in wire management because stuffing more conductors and breakers into the same space makes it harder to neatly organize the wiring, hindering troubleshooting and increasing the risk of accidental shorts. Secondly, improperly installed or non-compliant mini breakers can create safety hazards, including loose connections, overheating, and potential electrical fires, endangering the property and its occupants. Thirdly, using mini breakers to exceed the panel's capacity or violate code requirements can result in code violations, fines, and the need for costly rework to bring the electrical system into compliance. Instead of relying on mini breakers to overcome circuit limitations, a more appropriate and safer solution is to install a new sub-panel. Sub-panels offer several advantages. They provide separate power sources and circuit protection, ensuring optimal safety and proper circuit allocation. By adding a sub-panel, you can distribute the load more evenly, reducing the strain on the main panel and minimizing the risk of overloads. A sub-panel offers dedicated space for additional circuits, preventing overcrowding and making future expansion easier. This approach aligns with best practices in electrical installations and promotes a safer, more reliable electrical system. The physical space inside an electrical panel, often referred to as its cubic inch capacity, is a crucial factor in ensuring safe and efficient operation. Overfilling a panel with conductors and devices, such as an excessive number of mini breakers, can lead to several negative consequences. Firstly, overcrowding restricts airflow within the panel, which is essential for dissipating heat generated by conductors and breakers. Insufficient ventilation can cause components to overheat, leading to premature failure, insulation breakdown, and even electrical fires. Secondly, limited space makes it difficult to properly route and terminate conductors. This can result in sharp bends, strained connections, and increased risk of insulation damage, all of which can compromise the integrity of the electrical system. Thirdly, a crowded panel makes troubleshooting and maintenance significantly more challenging. Identifying and accessing specific circuits becomes difficult, increasing the time required for repairs and raising the likelihood of errors. The NEC mandates specific volume allowances per conductor to ensure adequate space for safe installation and heat dissipation. These requirements are outlined in various sections of the code, including Article 312. Consider NEC Table 310.15b16, which provides ampacity tables for conductors based on their size, insulation type, and ambient temperature. The ampacity of a conductor is the maximum current it can safely carry without exceeding its temperature rating. Overcrowding a panel can effectively reduce the ampacity of conductors, as the increased ambient temperature due to poor ventilation reduces their ability to dissipate heat. This can lead to conductors operating above their rated temperature, increasing the risk of insulation breakdown and fire. The NEC also addresses box fill calculations in Article 314, which specifies the minimum volume required for electrical boxes based on the number and size of conductors, devices, and fittings contained within them. Although these calculations primarily apply to junction boxes and device boxes, the underlying principle of providing adequate space for conductors and connections also applies to panel boards. When considering the installation of mini breakers, it's essential to evaluate their impact on the overall fill of the panel. While individual mini breakers may be smaller than standard breakers, their cumulative effect can be significant, especially if they are used to pack more circuits into an already crowded panel. Always consult the panel manufacturer's specifications and the NEC to ensure that the installation complies with all applicable requirements. As previously mentioned, a better approach is to install a sub-panel to accommodate additional circuits. Sub-panels provide dedicated space for new circuits, preventing overcrowding and allowing for better organization and wire management. They also offer the opportunity to install appropriately sized breakers and conductors, ensuring compliance with the NEC and maintaining the integrity of the electrical system. For example, if you have a 200-ounce main panel and need to add circuits for a new workshop, installing a 100-amp sub-panel would provide ample capacity for the additional load without compromising the safety or functionality of the existing electrical system. When installing a sub-panel, it's important to follow all applicable codes and regulations, including proper grounding and bonding, overcurrent protection, and conductor sizing. A qualified electrician should perform the installation to ensure that it is done safely and correctly. Another important aspect of panel board safety is the proper identification and labeling of circuits. Each breaker should be clearly labeled with a description of the circuit it protects. This makes it easier to identify and troubleshoot circuits, reducing the risk of accidental shocks or damage to equipment. The NEC requires circuit directories to be accurate and up to date, and it's the responsibility of the installer to ensure that this requirement is met. Regular inspections and maintenance are also crucial for ensuring the continued safety and reliability of panel boards. Periodically inspect the panel for signs of overheating, corrosion, or damage. Check for loose connections and tighten any that are found. Test the operation of breakers to ensure that they trip properly under overload conditions. Address any issues promptly to prevent them from escalating into more serious problems. The NEC mandates arc fault circuit interrupters or size in many residential circuits to provide enhanced protection against electrical fires. SIs are designed to detect and interrupt arc faults, which are dangerous electrical conditions that can ignite flammable materials. Consider upgrading existing panel boards with SIs to improve the safety of the electrical system. The specific requirements for SI protection vary depending on the addition of the NEC and the type of circuit. The NEC requires ground fault circuit interrupters or GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas to protect against electrical shock hazards. GFCIs are designed to detect and interrupt ground faults, which occur when electricity flows through an unintended path to ground. GFCIs can prevent serious injury or death from electrical shock. Like of size, the specific requirements for GFCI protection vary depending on the addition of the NEC and the location. It's important to stay up to date on the latest code requirements and best practices for panel board safety. The electrical industry is constantly evolving, and new technologies and techniques are emerging all the time. By staying informed, you can ensure that you are providing the safest and most reliable electrical services possible. Remember, electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Working with electricity requires knowledge, skill, and a commitment to safety. Don't take shortcuts or cut corners, and always follow the NEC and other applicable codes and regulations. Understanding the specific requirements for conductor sizing involves several factors, including the ampacity of the conductor, the ambient temperature, and the presence of other conductors in the same raceway or cable. The NEC provides detailed tables and calculations for determining the appropriate conductor size for various applications. Overcurrent protection is another critical aspect of panel board safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. Grounding and bonding are essential for providing a safe path for fault current to return to the source. Proper grounding and bonding can prevent electrical shock hazards and minimize the risk of equipment damage. The NEC provides detailed requirements for grounding and bonding systems. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning, utility switching, and other events. SPD can help to prevent damage to sensitive electronic equipment such as computers, televisions, and appliances. The NEC recommends the use of SPD in many applications. Electrical panels must be installed in readily accessible locations. This ensures that they can be easily inspected, maintained, and serviced. The NEC specifies the minimum clearances required around electrical panels. It's important to choose the right type of panel board for the application. Panel boards are available in various sizes and configurations, and it's important to select a panel that is appropriate for the load it will be serving. Consider the number of circuits required, the ampacity of the surface, and the available space. Ensure that all panel board components are properly listed and labeled. This indicates that the components have been tested and certified by a recognized testing laboratory. Look for the UL listing mark or other recognized certification marks. When working on electrical panels, always use appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. This can help to protect you from electrical shock and other hazards. Never work on live electrical circuits unless it is absolutely necessary. If you must work on live circuits, take extra precautions to protect yourself from electrical shock. Use insulated tools and wear rubber gloves and safety glasses. It's also a good idea to have another person present in case of an emergency. If you are not comfortable working on electrical panels, it's best to hire a qualified electrician. Electrical work can be dangerous, and it's important to have the expertise and experience to do the job safely and correctly. Remember to consider the impact of future expansion when designing an electrical system. Plan for future load growth by installing a panel board with sufficient capacity and leaving room for additional circuits. This can save you time and money in the long run. Furthermore, always refer to local codes and regulations. Local electrical codes may have additional requirements that are not covered by the NEC. It's important to comply with all applicable codes and regulations to ensure the safety and legality of the electrical installation. It is vital to ensure all electrical connections are tight and secure. These connections can create resistance, which can lead to overheating and fire hazards. Use a torque screwdriver or wrench to tighten connections to the manufacturer's specified torque. Also, conduct periodic thermal imaging scans. Thermal imaging can be used to identify hot spots in electrical panels, which can indicate loose connections, overloaded circuits, or other problems. Have a qualified electrician perform thermal imaging scans on a regular basis. Finally, consider using smart panel technology. Smart panels offer advanced features such as energy monitoring, remote control, and automated load shedding. Smart panels can help to improve energy efficiency, reduce costs, and enhance safety. Therefore, when working with electrical panels, it's important to prioritize safety, follow all applicable codes and regulations, and use best practices for installation and maintenance. With proper planning and execution, you can ensure that the electrical system is safe, reliable, and efficient. Remember that electrical systems are complex and potentially dangerous. If you are not comfortable working with electricity, it's always best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to do the job safely and correctly. Many breakers can save space but require careful management to avoid problems.